from up to down. Why? Due to the increasing of atomic size. Due to the increasing of atomic size down. And we said finally that there is an inversely relation between each atomic size and electronegativity. Okay? Now we are going to study the third property of element in modern periodic table as metallic and non-metallic property. Okay, the first after studying each atomic size and electronegativity, we are going to study the difference between metallic and non-metallic property. Metallic and non-metallic property. Okay, we studied the difference between them in last year in Method 1. We study the difference between metals and non-metals and how metals change to positive ion and how non-metal change to negative ion. Okay? After that, number 1, elements in modern periodic table are classified into what? Into 4 types. Elements were classified in modern periodic table as 4 types, which are number A, metals, B, C, metalloids, D, noble gas. Okay, what are the difference between them? First, metals. First what? Metals. What's meant by metal? They are elements which their outermost energy level have less than 4 electrons. Less than what? Less than 4 electrons. As lithium, its atomic number is 3. So its electronic configuration is 2, 1. So it's a metal. Sodium 11, 2, 8, 1. So it's a metal. Magnesium 12, 2, 8, 3. Aluminium 13, 2, 8, 3. So the element which their outermost energy level have less than 4 electrons, they are called what? They are called metals. Okay? They are called the metals. Abir, what's meant by metal?
They are elements that has less than 4 electrons in their outermost energy level.
Okay, sit down. Any element as metals or non-metals takes part inside the chemical reaction. So it either loses or gains electrons to make chemical bond and to share the chemical reaction. Okay? Metals lose or gain? Loses. Why? To reach the nearest noble gas. To reach what? The nearest noble gas. So sodium 11. 281. It's either to sodium atom to be 28 or to be 288. 288 only. Okay, 288 only. So it loses this electron and changes into positive ion. Magnesium 12. 282. It's either to magnesium atom to be 28 or 288. 288. So it loses 2 electrons, change into positive ion. And aluminium. Okay. So all metals tend to lose their outermost electrons, changing to positive ion. Okay. Now, what's meant by positive ion? Positive ion is the metallic atom that loses 1 or more electrons during the chemical reaction. What's meant by metallic atom? It's a metallic positive ion. It's a metallic atom that loses 1 or more electrons during the chemical reaction. Okay? It's positive ion. Positive ions carry number of positive charges equal to number of lost electrons. As sodium. Sodium 11, 281. So it loses one electron. So it becomes positive ion. Positive A ion as monovalent. Monovalent. Magnesium 12, 2A2. So it loses two electrons and change into positive ion, which is called magnesium positive 2, as it's a divalent element. Aluminum 13, 2A3. So it loses the 3 electrons, becomes Al positive 3. It's trivalent. Okay? So the positive ion carry number of positive charge equal to number of what? Lost electrons. As it loses 1, positive 1. Loses 2, positive 2. Loses 3, positive 3, and so on. Okay? After that, the electronic configuration of positive ion is similar to the nearest preceding noble gas or nearest preceding the inert gas. Why? Sodium 11. Sodium 11. Its electronic configuration 281. So it loses 1 in the outermost electrons. So it will be 28. 28 is the nearest preceding or following noble gas. Preceding or following noble gas. Preceding, which has 10 electrons, or its atomic number is 10, which is called neon. It's called a neon. So metals tend to be the electronic configuration of positive ion tend to similar to the nearest preceding a noble gas, not following noble gas. Okay, sodium 2811 becomes 28 as neon. Magnesium 2A2 loses 2 electrons to be 28 as neon. Aluminum 2H3 loses 3 electrons to be as neon 28. So the electronic configuration of sodium ion similar to magnesium